70% of our planet is covered by water, 326 million trillion gallons. However, only a fraction of that water is fresh water, only 3%. Yet even a smaller portion of that 3% is accessible and drinkable. Many parts of the world today struggle to find sufficient water for life. In fact, over 750 million people around the world do not have access to clean water. In the United States, we use water every day in countless uses. We use it for cooking and cleaning, for drinking, to take care of our lawn and plants, and for countless manufacturing processes. All of these uses require plentiful amounts of fresh, clean water. With modern water purification methods, water is first pulled from fresh water sources and then processed through a set of progressively finer filters. Then the water is passed through a flocculation process, which adds special chemicals to the water, which causes any fine particles left in the water to stick to each other, eventually settling to the bottom of the flocculation tank. The sediment is drained away and the residual cleaner water is pumped through sand and charcoal filters, which remove additional impurities in the water. A process developed only a few decades ago is ozonification, which pumps air and ozone through the water at high pressure, killing any bacteria. Near the end of the process, chlorine is added to the water as a final purification step.
Drinkable water is the problem in all around the world.
Reza Benyasad designed the treatment process when he was the senior water engineer for Gwinnett County Water System. Originally from Iran, he has traveled the world to investigate the best method for producing clean water.
The north than the other states really is undergrowing as a population, and this is only source of the water that has. The aquifer of the Atlanta is not rich, and even has the radon.
Many underground water sources are contaminated with radon, a radioactive gas that occurs naturally in various locations throughout the world.
But that was contaminated by the radon, and we advised them not to use that, so we serve them from our system, and now Grayson has a safe water. That is most important, and this is the most challenges for that. Of course, we are lucky that we have the Lake Lanier, because that's the really good reservoir for this drinkable water. But anyway, we're depending on the precipitation. It is true that the Atlanta area, Georgia, has a good precipitation up to 50 inches per year. But we do not have the good source of the snow that melting gradually. So whatever the rain coming, of course, part of it goes underground and part of it goes just to the stream that goes to the south. And then my last challenge was the UV, ultraviolet. The advantage is that when we're adding the ozone, it's killing the bacteria. But we cannot increase as much as we wanted. First of all, it would be so expensive. Secondly, it's not possible as a taste and the quality of the water. And so we try to go to some portion of the ozone, and then the rest of it leaving to the UV system. Advantage of the UV is that the UV will not kill the bacteria, but will act to the DNA of the bacteria, and so they cannot reproduce anymore. And so when we passing the water through the UV, it may have the bacteria, but they are not active anymore. They cannot produce anymore. So my last step was that put the UV on the system, of course not on the whole system, in some backwash water. That possibility may have the Giardia or Cryptos. For this person, I suggest to have the UV system, and then I retire.
In our world today, 80% of all diseases are caused by poor drinking water. Developing countries are working to be able to purify water more efficiently and at a lower cost. In conclusion, the South has some of the best water in the world. The technology that has been recently developed to treat water in the southern states is the most advanced in the country.